So in this lesson, we're going to warm up with some functions that are already given to us, and we're asked to add them, subtract them, and then find composition. But we're also asked to plug in numbers here. So this one's saying take F and add it with G. So what I'm going to do is I'm going to color code this so I know which one I'm talking about, or to make things a little bit more clear. So I'm taking F's function and I'm adding it with G. So I'm going to write those out first. So here's F's function, and then I am adding it with G's function, so that's the x squared and the 3. And so if I'm adding these two, let's go ahead and simplify it first before we plug in 5. So remember that 5 there is where x usually is, so that's going to be the x value that I'm plugging in. So if I'm adding them together, I just need to combine like terms. So this guy here, x squared, doesn't have anything to combine with, so it's just x squared. Same thing with 5x, there's nothing to combine with, so I'll bring that down as positive 5x. But then we can see that the negative 7 and the 3 are both constant, so we can add them together to get minus 4. From here, I can't combine anymore, so I'm going to go ahead and plug in my 5 for x. So if I plug that in, that's going to be 5 squared plus 5 times 5 minus 4. So working this out, 5 squared is 25, but also 5 times 5 is 25 minus 4. So if I take all of these numbers and I add them up and subtract by 4, I get 46 as my final answer. And that's it. So basically, take care of the operation first, whether you need to add them or subtract them, simplify that, and then go ahead and plug in your x value. It makes it a little bit easier on the process. All right, let's go ahead and check out this next one. This is g minus f. So let's go ahead and take our g function and write that first since it comes first. So g here is x squared plus 3, and our f function is 5x minus 7. So this is g, and I need to subtract it with f. From here, this one's a subtraction, so I'm going to go ahead and distribute that negative sign, because if I don't, I might forget that I'm subtracting. So I'm going to distribute first. So that makes a negative 5x plus 7. Now you can see I just brought down the first parentheses because there was nothing in front, so there's nothing to distribute, so I just brought it down. From here I can see that the 3 and the 7 combine, but nothing else. So I'm going to write the x squared first, and then 5x down, bring that down. And then 3 plus 7 is 10, and there we go. So now we're ready to plug in our number here for x. So if I plug this in for x, I'm going to get 2 squared minus 5 times 2 plus 10. So working this out, 2 squared is 4, 5 times 2 is 10, plus 10. So I noticed that the 10s will cancel each other out because these are opposite signs. So that means I only have a 4 left. So if I sum up all my numbers here, I just get left with a 4. And that's my final answer. So you can see I did the same process. I combined the function first. This time I had to do subtraction. And once I simplified it down, that's when I plugged in my x value, which was 2. All right, let's see if we can get comfortable with composition functions. So you might remember me saying this last time, but anytime you have a composition function like f of g in this notation, in the composition notation, it's easier to translate or switch this to parentheses form. Like ask yourself, what is the outer function? It's f, so we write f first, and then the inner function here we can see is g, and then we're plugging 4 into g. So always take composition notations and translate them to the parentheses notation, because it's easier for us to understand what's being plugged in when we see it in parentheses. Now, if you are comfortable from going this to working things out, then you're more than welcome to skip this step. But I find that this step helps most students tremendously. All right, so I need to figure out what g of 4 is. So if I go back to my very top here, I need to know what g is. So you always work from the inside to the out. So I need to know what g of 4 is. So I'm plugging 4 in for this equation. So I'm going to do that to the side here. So g of 4 is going to be 4 squared plus 3. Well, 4 squared is 16 plus 3 is 19. So it looks like I'm actually plugging inside this f a 19. So g of 4, we found out it's 19, so we're going to plug that number in. Now I just have to plug 19 in for f. So if I go to f here, this is 5x minus 7. So if I plug 19 in, oops, sorry, that's an extra parentheses. I need to multiply 5 with 19, so let me do this in my calculator. You can grab out your own calculator. 5 times 19 gives me 95 as my number. Then I need to subtract 7, so 95 minus 7 is 88. And that is my final answer. So just remember, with composition functions, it's easier to translate them to parentheses form so you can see what is inside and work your way towards the outer function. All right, let's get into our definition for today. So we're going to be learning something called inverse function. And inverse functions are often symbolized with this f that has a -1 as the exponent. This just means the inverse of f. But what inverse functions are they're functions that reverse each other. So let me put that in. So they reverse each other. And you're probably thinking, okay, what exactly do they reverse? Well, they reverse the x and y values. They switch. When you have an inverse, two functions that are inverses, their x and y values are switched, which means that their domain and range are switched. So in that case, in order to identify what is our original function and what is our inverse function, we use this notation to help us see that. So the notation is f inverse of x, or you could say f to the -1, but a lot of people don't say it that way. But f inverse to mean the inverse of f, and f is the function that you might have started out with. So let's first work with just the basic idea of what an inverse is. And that's just that the x and y's are switched. So we're going to switch our x and y. And so we're used to seeing coordinates where, you have your x and there's your y. So the first number is always your x and then you have your y. And so if I wanted to find the inverse of this set of points, all I have to do is just switch the x's and y's. So I just switch places with them. So let me write my set of coordinates here and set that up. So this first coordinate is 3, -5. Well, the inverse of that is -5, 3. Pretty simple. So all I'm going to do is switch the x's and y's, and that is a set of coordinates that is, oops, I think I messed up on the last part. Let me fix that. That should be a 7 and a -7. So that right there is a set of coordinates that is inverse to the original set of coordinates because their x's and y's are switched. So you can even say, if you started out with this set, you can even say that this guy is the inverse to this set. So on a basic level, inverses are x's and y's being switched for a function or a set of relationships, a set of coordinates. So when we are given this one here, same thing. We're going to find the inverse by switching the x's and y's. So I'm going to do that real quick. So this is -2, 2, -3, 3, and -4, 4. And that is all my 4 coordinates. And this is now the inverse to this function. Okay, so that's the end of this video. In the next video, I'll talk to you guys about how you can find an actual inverse of a function.